Shubhodayam. Welcome to all to the session of 7th batch of certificate course on Sanatan Dharma organized by Veda Samskruti Samiti in association with Vishwa Yoga Vidyapit. Today we'll be continuing with the Vedic mathematics, the second class by Dr. Goutham Mukherjee. Now we start the session with Vande Mataram by Venkat Narayan Garu.
वन्दे मातरम् वन्दे मातरम् सुजलां सुफलां मलयज शीतलां सस्यश्यामलां मातरम् वन्दे मातरम् शुभ्रज्योत्स्ना पुलकितयामिनीं फुल्लकुसुमितद्रुमदलशोभिनीं सुहासिनीं सुमधुरभाषिणीं सुखदां वरदां मातरम् वन्दे मातरम् वन्दे मातरम्.
ధన్యవాదాలు వెంకట నారాయణ గారు. Thank you very much. Now I request Shankari Narayan ji to do the pradhana, please.
1 minute meditation followed by 3 times Om. ॐ गणानां त्वा गणपतिगुं हवामहे कविं कवीनामुपमश्रवस्तमं ज्येष्ठराजं ब्रह्मणां ब्रह्मणस्पत आनशृण्वन्नोतिभिः सीदसादनम् ॐ श्रीमहागणाधिपतये नमः। ॐ प्रणो देवी सरस्वती वाजेभिर्वाजिनीवती धीनामवित्रयवतो ॐ श्रीमहासरस्वत्यै नमः। गुरुरेव गतिर्गुरुमेव भजे गुरुणैव सहास्मि नमो गुरवे न गुरोः परमं शिशुरस्मि गुरोः मतिरस्ति गुरो मां पाहि गुरो ज्ञानानन्दमयं देवं निर्मलस्फटिकाकृतिम् आधारं सर्वविद्यानां हयग्रीवमुपास्महे श्रुतिस्मृतिपुराणानाम् आलयं करुणालयं नमामि भगवत्पाद शङ्करं लोकशङ्करं शङ्करं शङ्कराचार्यं केशवं बादरायणं सूत्रभाष्यकृतौ वन्दे भगवन्तौ पुनः पुनः ईश्वरो गुरुरात्मेति मूर्तिभेदविभागिने व्योमवद्व्याप्तदेहाय दक्षिणामूर्तये नमः। असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा अमृतङ्गमय। ॐ शान्ति शान्ति शान्तिः। मातृदेवो भव पितृदेवो भव आचार्यदेवो भव अतिथिदेवो भव। ॐ सहनाववतु सहनौ भुनक्तु सह वीर्यङ्करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः। हरिः ॐ श्रीगुरुभ्यो नमः। हरिः ॐ।
ధన్యవాదాలు శాంతినారాయణ ji. Thank you very much. Gurubhyo Namaha. Now I request Goutham Mukherjee to carry on with this webinar, please.
Gurubhyo Namaha. Sarvebhyo Gurubhyo Namaha. Now I start the presentation. So, I hope everyone has practiced some of these, which were learned in this particular earlier session, namely the multiplication near a base. And there are so many different cases like below a base and above base, sometimes mixed, one below and above, and so that there will be a case of having vinculum, a negative number, and how to tackle that negative number. So this was the case, and where another thing was there. The algebraic explanation, of course, was, I hope there is no need to re-explain. Then there are cases like carry, where the carry is there, how the carry can be added to the last division of the first part. There are two parts actually, according to the algebraic equation. There are two parts, n into this n plus a minus b, or whatever is plus minus, and minus ab or plus ab, as the case may be. So these two parts are there, two parts, so this will be added. And similarly, there will be this case above a base, and there will be mixed case where it will be vinculum, so it will be, in effect, it will be subtracted. Now, today we'll come back to, sub-base. See, where the multiplicants may not be near a base, but it can be near a sub-base, common sub-base. Of course, this here we always consider the things both should be same. It is not possible that one is base for one is something else and base for another is something else. It is not possible. In this particular Nicola method, it should be always near a common base, or in this case, common sub-base. For example, now I consider a case called suppose 483 into 497. We find that they are far from a base, namely 1000 or 100 both, but they're near a sub-base. What is the sub-base? Sub-base is some multiple or even multiple. Although the common name is sub-base, it can be called also super base in that case. So here it is near, both are near 500. Now, how it is, we'll choose the base or sub-base, base and sub-base. Sub-base is 500, and no problem because it is near 500. But we can choose two kinds of bases. Say, I'll discuss one by one. If I choose 1000 as my base, then 500 is the sum multiple, namely half of that base. So, what is the procedure? I will consider Nikhilam Navatar Sarvam Dasata, keeping the 3 digits here. So, because this has 3 zeros, so we have to keep 3 digits. So, 483. So here it will just it is not Nikhilam Navatar is not possible. It is not 9 minus 4. It is not that. Only these two cases. We put a 0 here because we have to consider it is a 3 digit, and because it is 83, so 500 minus 483 is 17. I write it 017. Similarly, 497 is the 500 minus 497 is 3. So we write it 003 as it is. Just three digits have to be written. Just we cannot write 3. Now, similarly, we do a cross subtraction in this case. 483 minus 003 or 480, or same thing is 497 minus 017 is 48. Okay. And this is 17 into 3 is 51. Again, I write 051, keeping the number of digits intact. Now, since it is 500 is half of that, we again make half of this. Here it was also half, 500 is half of this, so we make half of this so that it comes to 240 instead of from 480. Now this 240051 my answer. Okay, is it clear? Now you consider this taking the same sub-base with taking 100 as a base. Here the number of zeros are 2, so you have to don't have to put extra. In case of 17, you don't have to put extra 0. Here you have to put extra 0 before 3 because to make it 2 digits. Here also we do same thing. 483 minus 3 is 48003, and 497 minus 17 is 480. Both are same thing. And we write 17 into 3, 51. Only 2 digits are there. Now, in this case, we have to, since 500 is 5 times 100, so we have to write 5 into, we have to multiply. Here also it is multiplication. The sub-base is multiplier of base, chosen base. So we have to multiply it. Again, 2400 it comes and 51. It answer becomes the same. That is the idea. Okay. I consider another case.
Gautam ji,
Yeah.
let's go to the back, this thing.
Any question?
So the multiplication is the same, 483 and into 497 in both cases, base 1000 and base 100. The net answer is coming as 240051 in the first case and 240051 in the next case.
240051 is the answer.
Okay. Thank you. Sorry.
Sir, I'm sorry to interrupt. I couldn't get that. How this 480, for the first case, sir, that you said that 483 minus 017. 480, how it came, sir, that I couldn't get it.
483 minus 3 is 480.
Okay, you have to minus 3, sir, first, huh? And thereafter, then multiply 17 into 3 is 51. Then
Yeah.
480 into 51. Okay, sir.
Yeah.
Then how come 240, sir? The 240
I multiplied it 480 by 5. I multiplied. So
no,
it
sir,
comes
in the first case, sir, this below the 240051. How
yeah.
240 multiplied by 5, sir? In both
No.
cases, sir.
No, answer is not into it. It is a continuous same number, continuous number. 240051. These two parts actually. So
The second one, the 48051 understood, sir. 480 minus 03 is equal to 480. and 17 into multiply to 51. First case I understood. The second one below the 240 and 051, we carry the same one 051. The 240 how it came, sir? That I'm
480
not.
by 2, sir. 480 by 2 is divided by 2.
Oh,
480
Because
divided by 2, and here it is
divided by 2.
480
1000
multiplied
to
by 5.
500.
It is this bracket is division symbol. This is division actually.
Yes, sir.
This
Okay,
is
okay.
division.
480 divided. Now, why should we do division here, sir? And
Because
then
the 500 sub base, my sub base is actually 1000 divided by 2. So here also I do divided.
okay, then we are taking not the case of 1000. We are taking 500 only, the sub base. Am I right, sir?
Because it is not near 500, 1000,
Sir.
but any tens power, it is near 500. It's some related to that some multiple of or multiplier of the base. So therefore, I'm taking like this. Therefore it is called sub base. This is the
Then
method to handle sub base.
then here
Uh,
we are multiplying 5, sir. 5.
Yeah,
Why?
because 100 is 5 times 500. So here also, with the algebraic expression when expression I get, you will give. It will be clear. Now consider another case.
Okay, sir. Right.
Both are
Thank you,
above
sir.
the sub base. So similar example I have given. So it is 517 is plus 017 and 503 is plus 003. This way we write. And similarly, it becomes 520 upon adding this 570 plus 517 plus 3, 520, or whatever, both are same. And then again, 17 into 3 is 51. And then again, divided by 2. This is, division. This division symbol is used in arithmetic, no? In all the states of India, this when I write something division. So therefore, instead of writing the division symbol 520 divided by 2, I put a bracket and this like this. I think no confusion is there. So 520 divided by 2 is 260, and then 51. This is 260051 is my answer. Similarly, in this case, I write by this same way, only 0 is not required, extra 0. This 3 plus this one is 520 and this is also 520 and this is also 51. But in this case, what I do, I multiply it by 5. So it becomes 2600 and then 51. Answer is same. Here is mixed base, sub base, but mixed case. So it is 483 is minus 017 and 507 is plus 007. So here also write 483 plus 7 is 490 and this is 119, but it's a vinculum because it is plus into minus is 9 minus. So basically it is minus. Whole thing is negative. So put a vinculum about that, vinculum symbol. And then in 490 divided by 2 is 245. And here it becomes 119. So now you have to again do this Nikhilam Namatas Sarmodasa formula. 9 minus 1 is 8. Here we do Ekonun, 245 becomes 244. And here it is 9 minus 1 is 8. 9 minus 1 is 8. And 10 minus 9 is 1. So this becomes my answer. Or it can say, basically it is the Nikhilam Namatas Sarmodasa is a shortcut way or mechanical way to evaluate for the subtraction. Basically, it is 24581. So this is the idea of okay, that's all.
Sir, 1 minute, sir.
Huh.
So sorry to interrupt. Like, sir, with the 483 minus 17, then 507 plus 007. Then we donate everything. We are not touched the 507, sir. It is still there.
No, 507 minus 17 is the same thing, 490. Because the way we create the 007 and 017 came, it takes care of both the thing. You don't have to, any one of them you do. It is the
Understood.
same thing.
Understood.
Always it is the
Understood.
same. It will be the same because obviously it can be proved. Very easy. You
Okay.
just try it. Huh? Okay.
Understood. Understood. Now I got it. Thank
So
you, sir.
now 5 into this becomes 2410. Here, this 119, one will be taken as carry. However, it is the same thing. You have to basically carry, you have to basically, this becomes, in the first go, it becomes 2, 4, 5, and this gets added here. And what basically the same thing, 119. So it is same thing. It here becomes,
Sir, I got a question, sir.
yeah.
Sir, this 119 and the 19, I'm not understanding this one, sir. How did you arrive this number, sir?
No, not 19. This is one is taken as carry. This is also 119.
But how did that number came, sir?
Because 17 into 17, 119. And then there are two places reserved for this one. This is actually carry. Okay.
Okay, sir. Thank you.
Now, when this carry -1 added, now we have to add is with the 0. It becomes, it separates it into two parts, 245 and -119. So it becomes, it looks like this down. When this carry gets added to this 0, it makes it -1 in this thousand, in the hundreds place, in the hundreds place. This one is in the tens place. Now this one will go to the hundreds place. So it will be like this. And it will be the same actually. So therefore, when we evaluate it, it becomes clear the fulcrum, it answers this. Okay. So now there are more cases like where we have to take 250 as base. See, 235 and 247. So we do 235. So it is 250 minus 15, and 247 is 250 minus 3. So we write similar way, 232 and 58. And here 58 is this is the thing. Okay. We didn't try other sub-base. It will be difficult. It is not because 100 into 2.5, it will not be a very fruitful one. It will be, cannot be handled that way. So this is the only way to have a sub-base, which is 1/4 of the base. Now, there can be cases where upon division by 2, it becomes a fraction. How to handle that fraction? For that, you have to have a very deep concept about the place value. Half in a place value. This half in a place value comes as a, say, half, if half comes in 100 place, hundreds place, the value of it becomes 50. Okay. So suppose half comes in thousands place, value of that will be 500. So that way it goes actually. So here it is a case where this half actually is 50 place. So we add that 50. So here we enter in the same way. This upon getting that is giving a carry of the 100 place. And but 13 when it divided by 2, we get 6.5. This 6.5, this becomes 50, and added to this, it become 200. 160 become 210. Then we do this 2 gets added to 6 and becomes 810 is the answer. Now the algebraic explanation of this this particular half and so on is that m into n minus n, m into n minus b is m into n taking out, and mn minus a minus b. Suppose I now do that thing. See, this was my, see, this is my m into n. This is my sub-base, so I consider m in this case is 1/4. So basically, this is mn minus a. And what is a? This 250 is equal to my, if this is my n, this is my n, and I choose m multiplier as 1/4. Okay. Now, mn, this is what 250 is my mn, m into n. Okay. And this is, first one is mn minus a, and similarly, this is mn minus b, where a is this and b is this. Now you understand what is happening here? This was my mn minus a minus b. This was already mn minus a. Again, I subtracted 3. So this 232 is my mn minus a, this part. Mn minus a minus b. And this is, this a and b we multiplied. This is the ab part. 45 is my ab. Now this was mn minus a minus b. Again, I shifted this part left. So it is multiplied, effect of multiplied by n. I'm dividing it by 4. So it is by multiplying that into m. M is itself is 1/4. So basically it is division by 4. Multiplying by 1/4 is similar, same as division by 4. So this becomes my whole thing, mn minus mn into mn, this one, the whole thing actually. And this 232 is my, only 232 is my mn minus a minus b, and 52 is my mn. This is mn. This is the 58 is my mn. And since it is shifted, sorry, this is what? This is, sorry, this is, yeah, mn is the whole thing. This is the m of that multiplication by m. m into mn minus, this was mn minus a minus b. 232 was this one. This is 232. Only mn minus a minus b is 232. Now this is, sorry, this is only m into 232, means m is 1/4. So this, and then the shifting to so many places is actually cleared by this. So one part is that we had learned the basic of this, namely all the basic arithmetical operations we learned from childhood, and we follow a procedure. We always do not bother what is the background algebra behind that. Everything has background algebra. Here we are applying another background algebra, and this corresponding to that there will be procedure. So this is my procedure. The mechanically following this part is called, we are following a procedure in this case. But in the background, what is happening? In the background, algebra, this particular algebra is working in this background, whole algebra. Okay, is it clear? Now we come forward, and so this ends my, because time is actually not that much. So unless we have
Sir, I got a question, sir.
we can go to the
Sir.
next topic.
Sir, I got a question, sir, with the previous
Yeah,
one.
please, yes.
So that 6.5 and 160, how is it derived, sir? 6210, and within brackets it's put as like 50 plus 160.
I'll tell you. This is actually, it becomes my evaluation
13.
becomes 600, this 6.5. Okay.
Yeah.
6.5, where 6.5 is in unit 10 100. Okay. You need 10 100. So 6.5 is my in hundreds place. And the tens place was having 6 and 0. But one carry is there. Carry is also in hundreds place.
Okay.
This 32 into 5
So-
becomes 160. So 60 I put in tens and 100, but 1 gets actually added to be this 6. I could have written, actually, actually, this is not the proper. I should not have done this. Actually, in fact, should have done 7 and let me do it here. This is good. So becomes 7.5. I could have written in this step 7.5.
Okay.
This 1 added to 6.5 becomes 7.5. Then 60.
Okay.
Now what will happen to this half? Oh, so you need
Okay.
10 100.
7.5 equals to, okay.
This 1 half contributing here actually contribute 5 here. This half will become 5 in this in the tens in it. So 7.5 becomes 7 and 60 plus 50. 60 plus 50 it will become. Okay. So it becomes 700, basically 700 plus 60. So far without considering any the half. But now if you consider the half also, it becomes 50.
Sir, 13 becomes 6.5, right?
6.5. So now added to this one if we add first, becomes
Okay,
7.5
okay.
and 60. Here I put
7.5
actually,
and
here I have done, I did another one instead of what I did, 1 and 160. 160 I added with 50 plus. First I added with 50. It becomes 210.
okay.
In any way you consider.
Okay. Actually, it should be like.
I think I'll change
Yeah.
it. It should be logical. It should be like this. You first add this 1 to 6. Not that first you add
Yeah.
this 50 to this and then you do. I'll change it. It is actually basically it's the same thing. Adding all these different components together, isn't it? Is it correct? Now it is clear.
Yes, sir. Yes, I got it.
Thank you. I request one that when you speak, anyone, please also put your video on so that I can
Oh,
see
okay.
your
Okay,
face.
sir. Sure. I'll do that.
Having togetherness actually. This is a matter of we are all together.
Yeah.
But on the voice, but we also want to see you sometimes.
Yeah.
Now,
I'll do that.
evaluate using Nikhila method. So these exercises are there. So you can please try this and we can discuss in the next class. Okay. Some of them will be having carry, some are above, below, and these things. You can design your own problem and then you can try your own cases. Now we come to another one, Tijog method. Here I do not go to higher levels, but I first give you the concept.
Okay.
So what we do normally, let us see, conventional mathematics we do side by side. Suppose I am asked to multiply these two. We should not forget conventional method. Conventional method is also, do not call it, these are non-Vedic or something like that. No. In India, so many different methods were developed. Some of them went to wide circulation. Those we call as conventional method. Those are all are same actually. Now we'll come to 5 and then you have to come to 215. Now we do like this into 6, 4, 8. So we add. Now what is the procedure is there? Now these two numbers, algebra actually, I think all all know this kind of algebra only. That 43 we do not put like if we say consider my 4 is equal to 4 we subtract when I substitute as a. Algebra is a method of actually substitution. The things will be substituted, then there will be calculations and then substituted back to numbers. So always may not be considered number. Algebra itself is a become very vast procedure, and there comes calculus, everything comes, and finally actually all are actually handling some or other number, but we do not have always see the numbers. In this case, but 43, see, in the childhood I used to think that like that. Suppose 4 is A and 3 is B. So can we write that AB is 43? No, because by AB will be my, if A is 4 and B is 3, AB will be 12 because A into AB will be considered as A into B. How to write 43 in algebra in that case? In that case, how to write? It is 10A plus B because basically it is 4 into 43 basically is 4 into 10 because it is in the under tens place and it is positional value system. 4 into 10 plus 3. So therefore, in algebra, if we want to substitute it A with 4 with A and 3 with B, we have to represent 43 as 4 into 10 plus 3, which is 10 into 10A plus B. 10A means 10 into A plus B. Okay? Clear? So similarly, the two numbers, it is also 2 and 5. With 2 and 5, we suppose this is C and this is D, become 10C plus D. So when we multiply 10A plus B and 10C plus D, in conventional method, what we do? First, we complete the unit part. This is this 10A plus B, we totally multiplied by D. This is my, suppose this is my A, this is B, this is C, and this is D. I first multiply with D. Then I will multiply by 10C and add 10C. The 10C, effect of 10 is this shifting. See, I put a cross here. This cross actually, this cross I shifted, no. So this is the effect of my multiplication by 10. And then I multiplied by C, which is 2. So this 43 multiplied by 2 becomes like this. So that was my idea that with unit digit, I multiplied the whole thing. And then with 10 digits, shift it and multiply by 10 digits. And again, I see it by multiply by 100 digits that way. But in this case, what I do, I group actually with the different unit. This is the unit group. This is the tens group. This is the 100 group. This way I group and then I evaluate. Like this, I actually this is the algebra I discussed. Now the procedure I will say discuss. 3 into 5 is 15. So write 5 here. And this carry I write below. Shift 1. This shifting is every step. Now here I do, see, here I did BD. So BD. Okay. This BD part is doing this and this. This is the B, this is my B into D. Oh, sorry. No, I'm sorry. B into D, this one. This is the B into D. Okay. 3 into 5. I do 3 into 5. 3 into 5. 15, 5 right here, 1 right here. You can do it any of the any sequence. Either you can do left to right or right to left. Both are the same thing here. Now, middle part, how it is coming? This middle part. This is the AB into AB. AD plus BC. AD is this one. 4 into 5 plus BC into 3 into 2. So 4 into 5 is 20 plus 3 into 2
plus
is
6.
6, so it is 26. So it is 26. This is 6 I write in the main place and then 2 for carry in the previous. Then comes last one. Last one, this is my AC part. A into C. So this becomes 8, 4 into 2 is, this was, first one is this, 4 into 2 was 8. Now this, we carry all added with this 5 and this 6 plus 1 is 7 and 8 plus 2 is 10. Okay? The procedure is clear with 2 digits. Now we come to higher digit. Here also, it is the same thing. Grouping is different. Here procedure, directly I jump to procedure, then we will explain. 4 into 2. Here, 4 into 8. No carry. 1 into 2 plus 4 into 5 is 22. 2 I write here, 2 is here. 3 into 2 plus 4 into 3 into plus 5 into 1. Because my, this 23. 3 into 6 plus 12 plus 5. 23. Now 3 into 5, this one. 3 into 5 plus 1 into 3 is 18. Finally, 3 into 3 is 9. So we added that and get it. Any question? Everyone got it?
Narasimhamurthy garu, you want to ask
Okay,
anything?
sir. Yes, sir. Yes, sir.
Okay. Can we tell?
4 into 2. 1 into 2 plus 4 into 5. That way. So this is the procedure. Now I go to higher one, 5 digits. So you can see I do not turn by turn to explain. But actually, this nowadays, this method, I'll come back to this one. This method is being taught in school, and it is called lattice method. Maybe that you, as I told, some students are also attending this class. Any student? Class 6, 7, 8, 9, like that. Anyone having accompanying with a child, student? We all are students at this in this building and this class, but any school student? Anyway, no problem. Lattice method is nowadays, it is called lattice method. Basically, it is Urdhva Jagapam. I will do it like this. See, it is how it is. This term actually we did this way, and maybe that intermediate things we have to memorize, and it will be very difficult. So it is writing like this. This is the same procedure written in a different fashion. So here we are multiplying basically 5, 4, 9, 8 with 2, 3, 1, 4. 2, 3, 1, 4. Using this Urdhva method, in this case written as lattice method. So we do 8 into 4. If we write like this, 3 in carry, this is the carry of this particular, and 2 this thing. Earlier we did in this way, but here it is already written this way. Now, 8 into 3, 8 into 1, we write like this. 8 into 3, we write like this, 24. 8 into 2, write this way. 9 into 2, this way. Like all this we call it, this total matrix we complete. Total this part, total this matrix part, we complete this way. Okay. Now we keep adding. Now the adding, add. So 2 directly comes here. 2 comes here. This is previous, carry of previous. So 2 has no carry. So this is the unit digit and this is the becomes 10 digits, no 10 digits. Now this will come to 10 digits. This will come to 100, 1,000, 10,000, lakh, 10 lakh, crores. This is 1 crore, 27 lakh, 22,372 is the answer. So, now 8 plus 3 plus 6. 8 plus 6 plus 3 is 17. So 7 I write here. Carry I put before that because carry has to be put in hundreds place along with that. 4 plus 9 plus 3 plus 6 plus 1 become 32 and the 3 and here and 2 is here. That way we add like that. You can do it this way. Basically, it is the same thing in a different fashion. Basically, those these same similar things we are doing in a different fashion, in writing in this explicitly in this, separating the each micro unit and micro 10 in a different fashion, and then adding like this in a lattice. This lattice or it can matrix we can tell also. Then in this way it do, and finally it comes. It is found that compared to the conventional method, this particular method, this particular way of grouping actually consumes less computer time. Means it consumes less power. That means where our lakhs of trillions of devices in the world, and each of them are always, suppose even to display this, suppose L is displayed here. To calculate the position of L, a background, not only that when we are giving some task of multiplication, even to place this L on my screen in this position, in the background, lot of multiplication was involved. And if each of this multiplication consumes some power, and the power can be made less by following this Vedic mathematics or this lattice method, imagine that megawatts of power will be saved throughout the world. You understand this thing? Every small computer operation may take a very micro or nano kind of watt of power. But we add to that trillions of device and it will easily come to shoot up to megawatts of power. So this, our Vedic mathematics of this method actually making it in the circuit, computer circuit, will actually save power. That has been proved. There is a paper on that. I may, somebody interested, I will give the reference. There is a paper on this, that how applying Vedic mathematics can save power. Achha, I now come back to the this one very in a sparse way I had put it here, and here also this vincula was applied. Now here, how sparse method, this 1 into 2 is 2 here, 3 into 2. I wrote in a sparse position so that this becomes very clear. 3 into 2 plus these things is 10. So 0 is here and 1 is here. So this 4 into 2 plus 1 into 6 plus 3 into 4, 26 becomes like the same thing, but in a very clear. Earlier it was very cumbersome. See, it was which is below what, it is not clear. But here it will be clear which is below what, how it is coming. This 4 into 6, 3 into 4, in any position you can see it. This will be 85. It would be center one. This one, this, and this. is the 50, it is a 58. And this way it goes, and when added here. But now, in this case, when we apply vinculum, 300, this 56. So, 5, if I write 5, 6 as vinculum, I add here and put, this becomes my, this one in the first lot. But actually, it actually will not do, because 6 is become my above 5. Sorry. No. This is not there. 6 and 4 above. So now again it becomes like 3, 6 and 4 vinculum. So this should become my 4 and 4 vinculum. 4 vinculum. So this is the idea here. And then when I do, there will be a lot of say for example 4 into 2 minus 4 into 1 plus 3 into 4. It becomes, so it is seen that carry will be less here. Here it will be all cancelled. See 2 into minus 4, 4 into 4, and 3 into minus 4. It will be only this one, only negative 4. So that way it goes like this. And carry will be less. Or when you get expert with this vinculum, handling vinculum, you will see that this applying vinculum. I have given the example with a less number. There could have been 9, some 9s and so on. I can give another example. So this is lattice method we discussed already. Now, comparison of different methods. Now here we do big number, 889, 890, 898. So this Uddhati Jagabham. Conventional method also in the next slide I discussed. 8 into 8, 9 into 8, 72. 8 into 8 plus 9 into 9, this is 54. 45. 8 into 8, 9 into 8, 8 into 9, it became 145. Sorry. This becomes 100. 8 into 8 plus 9 into 9 becomes 145. Now, 8 into 8 plus 9 into 8 plus 8 into 9 is 208. This one. And 8 into 9, 8 into 8, it becomes again this. 136. One thirty. 131, instead of writing 1 here, I wrote here 136, this one. And 864. So added to this. And when we apply vinculum, 889 becomes my 1 and 1 vinculum, 1 vinculum, 1 vinculum. And 898 becomes my 1 and 1 vinculum, 0, 2 vinculum. So when you again apply the same method, this becomes like this, and this actually gets converted to this 3 to 2. The 0 2 becomes 798. See this 1 and 202 negative becomes 798. Here in Mukherjee method, I did actually, you will find that vinculum and this is quite similarity is there some. 889 becomes my minus 111 and this is minus 102. So 889 minus 102 is 787. And this multiplied by this becomes 11322. This also another step I can do. 111 is plus 11 and 102 is plus 02. We learned already this procedure. Then this becomes 22 and this is 113. 11. This plus this or this plus this is 113. So this 11 becomes carry here. 11 and 322 becomes this one. Okay. This is by Mukherjee method. This was by Uddhati Jagabham. And I do by conventional method. Conventional method, we big numbers, we multiply 8 with 9, 8 with 9. But here we actually, we convert into conventional using conventional method, but using vinculum. So this converted into vinculum, this also converted into vinculum. Now, when we multiply this by 1 into this 2 into 1, 2 minus 2 into all these things becomes, this becomes minus and this all becomes plus. And the 0 I actually did shifted 2 because the 0 I just whole line I omitted because it is 0 is there, no point in writing 0, 0. So this is my shifting, and 0, this minus 1 becomes all, the minus becomes plus and plus become minus. 1 into this one becomes this one. When you add all these things, we come to this one, and which is called, we again converted into real number from vinculum. So this becomes number. Now you tell me, out of all these 4 procedures, which you feel it is to be the best or easiest? So this is the idea of learning multiple procedure using this Vedic mathematics, because we then have alternatives. Had we learned only the we all learn in schools, these are not taught still. Not many schools teach Vedic mathematics procedures, but we have only this option. So now when you learn multiple options, we have choice. So case to base case basis, you will find that you can find that different methods, actually different level of difficulties are there. So you can choose the best one if you feel yourself, because it may be also a personal choice, but still. So please do 1 or 2 reaction, please. Which you feel in this case is the best?
I think Gautamji, Sureshji wants to ask a question. He has Sureshji, you want to ask a
Please.
Yes.
Yes,
Gautamji, namaskar. Can you
Namaskar.
please go over the Urdhva process for 889 times 898? I'm not sure I fully follow the logic. The Urdhva yeah, the 889 times 898. Can you please go through that procedure? I don't know where I'm missing the logic here.
Oh, here. This part you are telling. This part you are telling. This one.
No, not the next one.
Huh?
The next column. The vinculum column.
Vinculum column. Acha.
Yeah.
How this 889 come? Actually, basically 1000 minus, because see, if we 1000 minus 111 is actually this one, 889. So therefore, this is this 119 is negative. This actually, this is the whole, you can see the whole
Yeah.
Okay. So therefore, we write like this. 889 is basically all are above 5. So what to do? So obviously you have to write ekadikonu purveno. Here it is 0 actually, because basically unseen 0 is there. So we ekadikonu purveno becomes 1, and then 9 minus 8 is 1, 9 minus 8 is 1, and again 10 minus 9 is 1. In this case, what is that? This ekadikonu purveno is 1, 9 minus 8 is 1, and 9 minus 9 is 0, and 10 minus 8 is 2. Okay?
Yeah.
I put a vinculum this way. And then we multiply 1 into minus, sorry, this is 1 into minus 1 into minus 2 is 2. Minus 1 into minus 2 is also 2, plus 0 into minus 1 is 2 again. Minus 1 into minus 2 is 2, plus minus 1 into minus 1 is 1, again 2 plus 1 is 3, and then minus 1 into 0 is 0, so it becomes 3. 3, okay. Now we consider this one. 1 into minus 2 is minus 2, plus 1 into minus 1 into minus 1 is again minus 1, and minus 2 is minus 3. This produces 0 and minus 3, and then again Sorry, if 1 into minus 2 is minus 2, and this is 1 into minus 1 is minus 1, so minus 3. Now, this into this is 0, this into this is plus 1. So, minus 3 plus 1 is minus 2. So, minus 2 is here. Okay. Now, we consider this one. 1 into 0, 0 it is. 1 into minus 1, and this is minus 1 into minus 1 is 1. So, 1 and that minus 1 becomes 0. So, here actually a lot of memory is required because for children it will be very easy.
Yeah.
They can memorize, they can small. Sometimes we get lose track at this higher age. But children actually, for children it will be very easy. But of course, the lattice method nowadays, it is again evaluated, invented. This becomes 0. This now we consider this one. 1 into minus 1 and 1 into minus 1. And so this minus 1 and minus 1 plus minus 1 and minus 1 is minus 2. Minus 2. And 1 into 1 is 1. Now this is again this one. So it becomes, if we clear the vinculum, 1000 minus this 202. Because 1 became 0. Vinculum now now 9 minus 2 is 7. 9 minus 0 is 9. And 10 minus 2 is 8. And 3 to 2 remain as it is. So this is actually basically vinculum end and vinculum beginning and end. Vinculum beginning and end actually here. So we have to consider this one as vinculum. This 3 to 2 remains as it is, 3 2. So this 1 202 Nikhilum method, actually it becomes Nikhilam Navata Sarmata Sutra, all from 9 except last one from 10, and this Eko Nunneno 1 actually becomes 0. So this was the period. And here, of course, you have understood.
Yeah, this method is easier for sure. Yeah.
Which one? This one?
Yes.
Yes.
Compared to Nikhilum Navata.
Yes, in one go you can do it.
Yeah.
And here it requires 2 steps, see? 2 steps. One for this one and another for this one.
Yeah.
So that become because the some people actually in earlier batches reacted that this is the best one. Anyway, that becomes the choice of individual choice. Now we come to, now I already explained this one to some extent, that how these digits, this one is shifted left and then shifted. This is conventional method. I explained the conventional method. No, with 2 digits I do it, with 3 digits I explained. Shifted, and now Udo Tijagabham, how it happens, it actually groups. This is the unit group, 10 group, 100 group, 10,000 group, lakh group. Okay. So this way it does. But actually, as I told, Tijag method, I written here. Tijag method has been proved to be more efficient to research. More efficient means more computing time, computing effort taking less, therefore less power, and it is saves power. So now some example, some exercises are given. Okay. Now today, what is the time actually is? So I can, I start today, tomorrow you can complete. Now, this is the division by Nikhilem method. Earlier we considered, any question remains, we can discuss in the next some classes, some classes.
Yes, sir. Sureshji has asked you some. Sureshji, you can go.
Okay. Now.
No, I'm clear. I'm
okay.
good. Thank you.
Okay.
Now, like we have considered earlier that near base, both the multiplication near a base or near a sub base or something like that. Here we consider if the divisor is near a base. Dividend can be anywhere. Dividend can be anywhere. But the divisor is near a base. So, for example, with one digit, very trivial one, I consider with 9. With 9, actually it is 10 minus 1, so we put 1 here. And 1 multiplied by 3. 1 multiplied by 3 is 3 here, like this. Multiplication. And it contributes. First before that, yes. First I draw it, because I am dividing by 9, it is one digit. Put this digit, put a separation point. Actually, I am considering here 34. First I should tell that. 34 divided by 9. So in conventional method, we do like this. We have to do 9, we put like this. When actually in Bengal, we put written, maybe that some states may differ to some extent. I put this way. And 9, see 9, 9, 9, 9, 1, 9, 2, 9, 3. I put a 3 here. Put 27 and multiply with negative. I do show it is 7. 3 is my quotient. This is Q and this is R. Okay. This is my conventional method. Here, what I'm doing, I'm not doing that way. I'm not dividing by 9. Because there can be it can be 999 also. It can be 879 also. Very big number. We have to very big numbers. We have to do this way, table of those numbers and so on. We do not do like that. Whenever it is near a base, it is 8, 9 and so on. It's 7, 8, 9 and so on. It is quite high and near a can be considered as a near a base. So what do? We divide by, as if dividing by the nearest base. In this case, nearest base is what? The nearest tens power is 10 itself. So dividing by 10, upon dividing 34 by 10, what is happening? 4 becomes my quotient, remainder. 4 becomes my remainder, and this becomes my quotient. As you said that, but we are not dividing by 10, we are dividing by 9. So each of the place there will be some deficiency. And what is the deficiency? This can be this is the procedure. Now while I discuss the background, but actually you follow the procedure. 1 into 3, you put 3, and then just add that. So that in 30, the 3 is this contribution of the deficiency. So it becomes, that gets added to the remainder. So if I divide it by 34 by 10, becomes my 4 becomes my remainder and 3 becomes my quotient. But in this case, 3 more will be added. To 3 will remain my quotient, and now my new quotient will be, a new remainder will be 7. So this is the thing. Similarly, you do here also 1 is there. 1 into 6 is 6, and it contributes to the remainder. Here also, this 1 is there. 1 into 1 is 1. Now 2 plus 3 is 3. The 3 into 1 is 3. This becomes my remainder. And here you have to understand it a little. You understood? Here the procedure is like that. First I talked about the procedure. Now background I will tell later again. So 1 into 1 is 1. This contributes towards this digit. Then 2 plus 1 is 3. And 3 into 1, this 3. 3 into 1 is 3. That is. Now I again add 3 plus 3 is 6. This 2 plus 1 is 3 and 1. So 13 becomes my quotient and 4 becomes my remainder. Here you are a slightly different case.
Please repeat that one more time.
This one.
Yes.
So this I write later. Actually, I remember it here. So I'll tell you. 1 into 1 is this was clear. 1 into 1 is 1.
Yeah.
Okay. Now 2 plus 1 is 3. So I write like this. 2 plus 1 is 3. I remember it. Do not write first. Right, I'll do it later. This 1 into 3, 1 into 3 is 3. Okay, false like that. 1 into 3, this becomes 3. 2 plus 1 is 3. Not 1 into 2 only. 1 into 1 is 1. 1 into 3 is 3, becomes 3. So now we add 3 plus 3 is 6, and this 2 plus 1 is 3, and 1 is 2. Here I do 1 is my this thing, deficiency. 1 into 2 is 2. 5 plus 2 is 7, and 1 into 7 is 7. Okay. 1 into 7 is 7. Now 7 becomes my 10. 10, 27, this 25 plus 2 becomes 27. 27 becomes my quotient, and 10 becomes my remainder. But 10 remainder is not possible in this case. Again, either you only then add subtract, or you do so by subtraction. I can do also like this 1 and 0, and then 1. This 1 gets reflected here. The 1 becomes this 1 gets contributed to 1 becomes my. Basically, it is 27 quotient. 27 quotient and 10 remainder is the same as 28 quotient plus 1 remainder. Isn't it? That quotient remainder 10 actually becomes remainder 1 and contributes 1 more towards the quotient part. So it becomes Q and R. With more example, will be more clear. With bigger number and applying. Here is very actually chosen numbers are very small. Otherwise, it could have been create a much more and more bigger remainders, and that will create more problem here. But even the conventional method, even big numbers like this will create problem for here. It is so transparent. 1 into 1 is 1. 2 plus 1 is 3. 1 into 2, 1 into 3 is 3. This 3 plus 3 is 6. 1 into 6, 1 into 2 is 6. 1 into 6 is 6. 6 plus 1 is 7. 1 into this 7 is 7. And then becomes 9. So 13 becomes my 1, 3, 6, 7 becomes my, well, add this thing, of course. 1, 3, 6, 7 my quotient, and 9 becomes remainder. And 9 actually becomes 0. And so it is actually contributes towards quotient. So quotient is increased 1, 1, 3, 6, 8. 1, 2, 0, 0, 2, 1. Even for this one, only conventional method will take a lot of time. Here you do very, you can jump. These examples are purposefully taken like that. 1 into 1 is 1, 2 plus 1, 3, 3, 3 plus 0, again 3, 3, 3, this becomes 3 plus 2 is 5. Here you do simply, don't have to say that this into this. No, don't say that. This 1 you put here, 2 plus 1, 3 put here. 0 plus 3, 3 put here. 0 plus 3, 3 put here. 2 plus 3 put 5. 5 plus 1 put 6 here. Then we add all these things. This is quotient division. It is so clear without any further complications. But if you consider this conventional division, it will take very so many steps. Unnecessarily you do tables of 9 and then 9, this one, this 3, 30, 9, 3, then 3, 27, again 2, 30, 9, 3, 37. What is required? Why it is not required? You do simply this one, you first as if dividing by 10. So you just put a line between the quotient and remainder, and you keep on doing this contribution of 1 every place. You just keep on adding, and then here also is 1 is there. So 1 into this 1 into 1. This 1 is just put here. 0 plus 1 is 1. Again, 1 plus 1 is 1 plus 1, 2, 2 plus 3, 3 plus 6 is 9, 9, 9, 9 input here. 9 plus 4 is 13. This 13 plus 9 becomes 22 my remainder, and this adding this thing become my quotient. And the 22 again I do 9. This 2 is 2 I put here. Into this 2 and 4 and 4. This becomes my 4 becomes my R. This 2 gets contributed towards 3 and makes it 5. So you'll find that compared to the conventional method, even dividing by 9, it becomes very transparent and very clear because it's very so close to the base. Now I come to the next one. Division by 8, 7, and 6. So it's more and further from the base, it becomes more and more complicated. I will see that, and so that this method, Nicolet method, basically is the most suitable for division. Nicolet method is more suitable for closer to base. So 8 here it is the deficiency from 10 is base is 2. So each 20 will contribute 4 here. So we're going to divide a line 2 and 3, and 2 into 2 is 4. This 4 contributes towards quotient, and they add this. Here also 2 into 3 is 6. 6 plus 1 is this one. 3 into 2 is 3 to 1 is 3. So 1, 5. 3 here in this case deficiency is 3. 3 into 2 is 6. 6 in case of 6. 4 into 1 is 4. 1 and 15. 23 is 4. দেখছো তুমি আমাকে ইয়ে করে দিলে না কনফিগ ইয়ে করে দিলে How much time is there? Now you I'm sorry, there is
It is
one
15 minutes only.
10 minutes.
15. Yeah, 10 minutes only. 5 for Pradhan.
Acha. Now you consider this one, 234 and 2. The 2 into 2 is 4, and then 2 into 2 is 4, and then 4 plus 3 is 7, and 7 into 2 is 14. Yeah, 18, and then again it becomes, to do something, it becomes 29, because 18 is again, we could have done it with 18 also. This becomes 6 and 2 and 18 by 8. So this 2 becomes by quotient and a remainder, and then 27 plus 2 becomes 29. Now 345 divided by 8, 23, 6, 6 plus 4, 2 into 10 is 20, and becomes 20, 40, 33. Because this is, the 25 is, I'm sorry, 3 and 1. These 3 gets contributed to us 40. Okay. So now, 2 or more digit number requiring single processing. 89. So here is the basis. 89 is what? Nearest 10 power is 100. So I put 2 zeros are there. I put 2, leave 2 and put a dash here. This is the first procedure. Or I can say in the background that had this 111 be divided by 100, what would happen? What would have happened? 1 would have been my quotient and 11 remainder. But in this case, it is not. It is actually 11 deficient by that. So each of these 100 will contribute 11. So the 11 will contribute towards my, my remainder. So it becomes my 22. Similarly here, 13 into 2 plus 20 into 26. Here 12 into 3 is 36. Like this way. 112 into 1 is 112. This contributes towards remainder, everything. 211 into 2, 422 contributes towards remainder. So imagine that dividing by conventional method. I have to this 789, I have to find what multiplies this. So this is so shortcut. Now, but this is single processing. But there may be required multiple processing like this. 1111 divided by 89. So again, I divide by 100 or put 2, leave 2 and put it 1. Some problem I have. So this becomes my, now 1, this first 1 is multiplied by 11. I put like this one. This is the procedure. 1 in this quotient place and 1 in the remainder place. 1 plus 1 is 22. The whole thing becomes in remainder. This whole thing is added and this gets also added, becomes 12 and 40. 12 becomes my quotient and 43 becomes the remainder. Here 211. So 211, this into 2 is my 4 remains here and 22 here. And then 1 plus 4 is 5, and 5 into 211 is 1055. This 6 added to this one, added like this. This way it is written, it is added like that. Now, this again requires one more processing, multiple, therefore I written multiple processing. So this 1731, and again, this is 1731. This actually contributes 209, 942. Because the same number of digits, I just 942, I just do subtract it. Because same number of digits, we cannot follow this procedure. So basically 153. So from here, it gets this 173 become basically 2 and 153, and then this 2 gets added to 25. Okay. But there can be multiple processing like this. Here also it become this following the same procedure. 331 again I did. 739 is less than this, sorry. But here if you see, here maybe three processing are required here. Three processing are required. $211 and this 422. 2 here and 2 here. And and this 2 here. The 3 plus 4. 3 plus 4 becomes 7. 7 into this is 1477. 1477 right here. Actually, if we write it like this, it becomes actually 14. Whole 14 is actually below this 2 here. So actually 3 plus 4 was there. So 1477. Now again 1 plus 2 plus 14. 17 plus into this one is 3587. The whole thing added here. And then if we add like this, it will become 287. Again, the 5013, I do 5013. And into this one, 1055, 1068. So again, 1068 I do, finally becomes like this. Now this 5 this 1 plus this 87. 287 plus 5 plus 1 becomes 293, and then 279 becomes my remainder. This is remainder. So, oh. Here, more further from this one will create problem. I have shown this in another slide. 654, yes. This was there, longer complication I have written. So here see, you have to 1, 2, 3, 4 times. So all these 4 quotient will be contributed. So therefore, this basic mathematics is state division. It will be learned in a different course. Before that, I have written this one, 919. Requiring multiple processing here, 919. But here actually, I follow another procedure. 919 is or 81, but 81 I put 1 and 2 1. So this 1 and 2 1, I put 2 and this 4 2. Because here you do, it will be very, see 9 1 to 10. So it will be looking very complicated. But here it will be a little easier with all the vinculums properly done. So if we add that, it will be like this. And then this 1 4 becomes 6, so 640. Directly it comes like that. This special case, I'm going through it quickly. You just consider it again. Any point I can do, and I can go back and clarify it. Now, Nicola method, how can we apply it to some sub-base technique? I considered this 1011 divided by 23. I find that 23 is not near anywhere near any base, but it is near. If I multiply it by 4, it becomes near base. So first I divide it by 1011, I divide by 92. So following the same procedure, 10 becomes my quotient and 91 becomes my remainder. Okay. And then see, if I divide by 1011 divided by 92, if I do, 10 becomes, so basically 920 plus 91, isn't it? Is equal to 1011. So that is the idea here. I got it like that. So 10 and now, since I did into 4 here to get 92, obviously it will be 4 times. I'm not dividing by 92, but I am dividing by 23. So my quotient will be 40, but 91 will be my 91 remainder. 91 remainder was fit for 92, but 91 can be again having like this. 91 minus 2 into more this 91, if I divide by 23, it becomes 3 and 22 becomes my remainder. So 40, finally 40 becomes this 40 plus 3, 43 becomes my quotient, and 22 becomes remainder. Is it clear?
Goutham ji, with your permission, we'll have prayer, then we may ask. Okay. Madam Shankari, Pradhana, please.
स्वस्ति प्रजाभ्यः परिपालयन्तां न्यायेन मार्गेण महीं महिषाः गोब्राह्मणेभ्यः शुभमस्तु नित्यं लोकाः समस्ताः सुखिनो भवन्तु काले वर्षतु पर्जन्यः पृथिवी सस्यशालिनी देशोऽयं क्षोभरहितो ब्राह्मणाः सन्तु निर्भयाः अपुत्रा पुत्रिणः सन्तु पुत्रिणः सन्तु पौत्रिणः अधना सदना सन्तु जीवन्तु शरदां शतम् सत्यं वद धर्मं चर स्वाध्यायान् मा प्रमदः सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामयाः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत् ॐ शान्ति शान्ति शान्तिः पूर्णमद पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते ॐ शान्ति शान्ति शान्तिः सर्वे जना सुखिनो भवन्तु स्वस्ति.
Thanks, Madam Shankari, for the prarthana. We will rise for the national anthem. जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड उत्कल वंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभाशिष मांगे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हिंद. Now I request any doubts on the presentation by Mr. Goutham.
Venkata Narayan garu, I have one clarifying question.
Goutham ji.
Goutham ji, thank you so much. You're putting a lot of effort into this. I have had this Vedic mathematics book for a while. I taught my kids some of these early tricks in algebra. Now they're grown up. But I'm wondering, is there a follow-up book that has been done? Is more research done on what Shankaracharya ji did in the 60s? Are there additional work being done now to expand on his work? And if you have any pointers, I would be very interested.
Now, this can be thought actually with taking the basic ideas one can do, but actually this procedure, to learn a procedure requires some mental, sort of mental orientation. That mental orientation may not always come by intellect. That is the main, where the people didn't discover new procedures. I had gone to different mathematics professors in universities and IITs. They get surprised and get reluctant to sometimes. They tell, why not by calculator? They started arguing like that. So they feel that, why should we learn another procedure? Why not by calculator? Okay, this way. So this was, I will teach maybe by tomorrow it will come, or day after tomorrow. So when we learn this procedure, this recurring decimal, it is so obvious. They get do that thing. They get surprised, but they do not admit that is something new, is that something very good is there here. Say 1 by 29, one line I can learn this way. They will start arguing. But calculator, you cannot. Calculator, you can do up to this, suppose maximum up to 9, or some calculator up to 15 places. But not these 29 places. Sometimes in 1 by 59, you get 59. You get 58 decimal places. You cannot do it by calculator. Neither by Excel you can do. But by Excel you can do, but using that Vedic formula, that quotient and remainder formula is there. Using this particular Vedic ordinal method only, you can do it. So, but they are reluctant to learn something new. So unless there is a mental, mental focus, you can say that mind actually raises a lot of learning new things. So unless this is overcome, the normal intellectual people cannot discover new things. So Swamiji did meditation and so on. The meditation, actually, this is our, since it is a Vedic all course, actually, this is Veda Samskruti Samiti. I tell here that this by meditation and going to Samadhi, it gives a lot of new power to mind, so that mind may get a different focus and might become more flexible to new procedures, even to discover new procedures. Normal intellectual people, if their mind is not do not accept to take new procedures, so they will not be able to discover more. That's how
agree.
not much thing is happening compared to.
Yeah, I would love to see more research done
yeah.
in this one. Yeah.
Okay. Any other questions, please? Okay. Thank you, Goutham ji, for what we may informally say a brain heating session. We'll do more.
But actually, you please practice it. Today, whatever today is learned, you start with the smaller ones, and then you start, you learn this one, bigger one, higher ones, and then you think that.
Yeah, we have to calculate more and more examples.
Yeah.
Okay.
So
Thank you then.
some procedures, some exercises are given here. This one. Okay.
Okay then. Thank you. And I'm stopping the recording.
Okay.